Hello world and welcome to How to Code That episode 5. And today is gonna be exciting because, and kind of mystical also, because we're gonna play with water reflection using Three.js. So we're going to reproduce this effect using Three.js and some custom shader. Then we're gonna tweak some parameters like how strong the reflection is, play with the speed as well, and how reflective is the surface. Then we're gonna add a nice sky full of stars just to make it a little bit more mystical. And we're gonna add more objects to see how the reflection is working. So the idea is to reflect an entire scene with Three.js, and we're gonna see how to make that. You can get access to the code of this demo by supporting my channel on Patreon. Don't forget to subscribe to support me and activate the notification so you'll be ready when I'm uploading a new episode. And please guys, if you finish the exercise, send me what you did on a GitHub repository or whatever. I'll be super happy to share it with other people, and don't be shy, I will not judge you. And it's always good to see what the community can do. So thanks, if you can share, that's perfect. Also, I'll be happy to see that people are actually doing the exercise, so that'd be great. So yeah, if you're happy with what you did, just send me the repo. I'll be super excited to see it. Okay, so let's get started. First thing we're gonna do is that we're gonna download the Three.js template that I made. So the link is in the description, and you can either clone it or download it as a zip. Okay, so you should have a bunch of code already. If you're familiar with the other exercise, it's the same as the 3D exercise. So you just basically have a normal class with all the Three.js scene already installed for you, with just a sphere and a camera. And that's pretty much it. You have some CSS just to make it full width, and some utils and manager to load your textures. So first thing you're gonna do is gonna open your terminal, go to the root of the project and do npm install. As usual. Then we're gonna do npm run dev. Alright, then you're gonna click on this link, and you should have that in your browser, showing your browser. If you don't have that, pause the video, take your time, just be sure you downloaded the correct template. There is absolutely no rush. Okay, so once you have that, I think we can start. So first thing we're gonna do is we are going to remove the things that we don't need. So in the index HTML, we can remove the footer and the title. I should remove the footer actually for later. Let's make a special version for it. Okay, so now as you can see, we just have a sphere and an X. Helper axis, sorry. Okay, so let's have a quick look of the JavaScript code, just to be sure. So here is the main scene that is called in the index, imported. We are loading texture, matcap. We're adding some stats here. We're adding some GUI. We are creating a scene with a background. And we are adding a camera, controls just to allow us to drag a sphere, and a function that is checking on every size, and of course a function just to render the scene every frame per second. I am not going much into detail because you can pause and everything is commented, so you can just read it and see what's going on, but that's just really the basics of Three.js. And today we're gonna see how to make reflection, and you will see it's not that hard. Using Three.js, the only thing that is kind of complex is that I'm gonna use some custom shader to have this water effect on it. Okay, so let's go. So first of all, we're gonna change the background of the scene, and we kind of want to make it, we want to make like a night blue sky, right? So we are going to reuse the same color here that I did. Oh, also, you can change the color. Pick the color that you want. I think you can do also other effect. Just be creative. But I think a night sky is great for this reflection effect. Kind of like in the lake or something, the night could be fun. But yeah, feel free to be creative and do your own stuff. Okay, so I'm just picking this color. And here you can see in the scene background, you can just easily change the color using that. And it's gonna change the color. Okay, right, so we have our night sky almost. Don't have the stars yet, but we will see that later. Okay, now we have an object sphere. It's great, but it's using a matcap and I don't want this effect. Okay, so we have a material here on the sphere. So if we go and set sphere, let's say that's use a matcap texture. So that's this blue shade with a fake light on it, but we don't want to use that. We're gonna use a real light and a material that can react to light. So if we go to the Three.js doc, you have different material that can react to light. So you have the lumber, the fungus also is great to have it more like kind of metallic. But here the lumber I think is great for what we need. Okay, so we're gonna do here, instead of mesh matcap material, we're gonna use the lumber material. And we're gonna import it from Three.js. So here with VS Code, I'm just add it here in your Three.js. I'm going to do that the whole time just to let you know, but my VS Code is importing the stuff for me, so that's pretty convenient. Okay. And we're gonna use a color and we're gonna use white. Okay, let's see. Okay, so unfortunately it's black, but that's totally normal. That's because we are adding a material that is reacting to light, but we didn't add any light. So let's just add some light. So for that, we're gonna add what we call a directional light. The directional light is kind of like comparing to the sun. It's like you have like a giant light somewhere and it's going in a specific vector direction. And so all the objects in your scene will be affected by this. Even if you're close or not to the light, the direction is like global on the entire scene, like the sun. So that's what we're gonna do here. We're gonna create a new method here. Set lights, we're gonna add more lights. And as we said, we are using the directional light here from Three.js doc. And we're gonna import it. And we're gonna use this scene because that's our scene. And we're gonna add the light. Then we need to call the method, of course. So here. Okay. Let's see. Okay. So now we have a light coming from, looks like the axis is like on the Y, but we kind of want to come it from, I don't know, from the X axis maybe. So for that, when using a directional light, you can change the position of it. And it's gonna change the direction. I know it's weird, but that's how it's working. Here, position X, I'm gonna put it to 1. Okay, so now we have our lights coming from, I guess the default is Y1 and X, and now X1 and Y1. Let's see, but yeah, default C is 1 in the Y-axis. So now we have 1, 1, 0, basically. So that way it's in diagonal, like that. Cool, then we have the intensity here and the colors. The color will be white, intensity 0.5. I think it's great, we can maybe increase it a bit. Okay, yeah, whatever. So now as you can see, it's white, but it's kind of dark here. So, sorry. You can see it's white, it's kind of dark here. So let's add what we call an ambient light. So an ambient light, it's basically a light that will be applied everywhere in your object in all the direction. It's kind of like, you're in the... If it's dark and there is the moon, it's not going to be totally dark, right? Everywhere it's going to be a little bit bright because of light reflection and this stuff. So ambient light is very convenient for that. And we're going to use an ambient light. So let's go to the dock and then go to ambient light. Okay. And as you can see, using ambient light is super simple. There is no direction. It's just a global light. But if you don't have that, all your scene is gonna be pretty dark. So it's always good to have one. Okay, same, I'm gonna import it from Three.js. And here we're gonna add that to the scene. So yeah, keep the Three.js doc with you when doing the exercise. That way you can easily copy and paste the stuff. All right, now we have a nice white sphere. I think it's looking pretty great. We can also here make it a little bit more. So this will be full white, but we don't want that, right? So a little bit more gray, maybe. Well, that's too much. Maybe A. Yeah, whatever. Okay, I think it's great like that. I'm never happy. Okay, I think that's great for what we want. Yeah, I think that's great for what we want. Cool, so now we have a sphere. And now let's make the reflection. Okay, so now we have a nice white sphere, but that was not really the purpose of the exercise, right? So let's get right into it and let's start to create the mirror effect. So first we're gonna check the Three.js example. It's always great, like the Three.js example is amazing because when you want to do an effect in 3D and you don't know, most of the time you will see it in the example. And from that you can start to explore, see how it's working, and then customize it yourself. But that's always great to start with Three.js examples. So here we're gonna see mirrors, and there is one. Cool. So as you can see, there is a mirror effect, and it's working great. There is also even like 2 mirrors, and they are like reflecting each other. It's amazing. So we're gonna see how this is made. So for that, you can click on the little thing here, view source code, and you will have access to the source code. Perfect. So let's have a look. So here, okay, a bit control. Oh, weird. Okay, it's using something called reflector. Okay, so that's probably what they are using to make the effect, right? So let's see. We have the renderer, the camera, great. And here, let's see, reflectors, mirrors. Okay, so all the mirrors parts are probably here. Well, that's a lot of stuff, but we can just check for the ground mirror, right? So this ground mirror, that's pretty much what we want, right? Also. Okay. So we're gonna see, and we're gonna just copy it. And here we're gonna set reflector. We're gonna call a method, and we're gonna do, oh, sorry, I'm not in the, I was in the final exercise that I've made. So here we're gonna add this set reflector. There is no, the order doesn't matter here. And we're gonna add it after the light, for example. Okay. So, sorry for my voice, I don't know what's happening. Okay, so we're gonna just copy and paste. Okay. So, here we have a 3 circle geometry. And we're gonna import it from JS. Here we have a ground mirror. We're gonna call this so we can add access to it to our class. And here we have a reflector. Because as you can see, a reflector is not imported by default in Three.js. It's an add-on. But you can easily import it using this. So if you do three add-on object reflector, you're gonna have access to it. Here, I'm gonna add it. It's kind of like the orbit control. It's the same. It's not here by default, but you can add it easily. And we are adding the reflector. Here, we are seeing multiple things, but we're gonna see that later. The position Y, I think we want it to be really at 0, because it's gonna be the floor. You can see there is already a rotation, but that's the good rotation because that's what we want for the ground. And save. Okay, now let's see. Huh. Did it work or no? Let's see. Hey. Okay, cool. So I think this is already working and it was pretty fast, right? We did almost nothing. Just use the reflector and it worked. So as you can see, it was pretty easy to make a mirror using Three.js, right? So now we just want to be sure that the sphere is not under the mirror. And you can see here. And as you can see, it's not only reflecting the sphere, it's reflecting the whole scene. It's also reflecting the axis helper. And everything is reflected. So that's pretty amazing. And we're gonna see how it's working. Okay, so now that we have seen that, we can also see what we can do with that reflector. So you can see this is using a circle geometry. Well, that's basically the plane or the surface where we're gonna render the mirror. So where we're gonna render the reflection of the actual scene. So here you can see this is the radius. So if we put it to 5, here as you can see now we are reflecting only in this little circle. So if I'm, so yeah, it's in the middle, so it's like, okay. So if I'm here, see, it's gonna reflect only in this circle. So now let's add a little bit more shapes and movement to make it more dynamic and alive. So first we're gonna add, so here we have a sphere. We gotta call it sphere mesh actually. Sphere mesh. And here in the render, in the draw function, so this is called 60 frames per second. We're gonna make the position move, position Y move, using a math sinus, so the value will be always between 0 and 1, and we're gonna use time. Time from the request animation frame parameter. So this will give us the time when you started the website, basically, and it's always increasing. If you do that, see, don't be epileptic, don't watch that. Okay, I'm gonna stop it quick. It's going super fast, but that's because time is going fast, so we're gonna divide it by, I don't know, 1000. Okay, and now you can see it's moving slowly. But it's moving from -1 to 1. That's what sinus does. So we want it to be above, right? So probably 2 or 3. Okay, so now we can see that there is movement and the mirror is still working. There is still reflecting this in real time. So that's pretty cool. Okay, so now let's add, for example, another shape. So we can create a new method, but I'm gonna just put here just to be fast. Let's see, I'm gonna use a geometry. You can pick any geometry you want. Be creative again. I'm gonna use the torus because I like donuts. So let's go. So torus geometry. And here we're gonna reuse the same material for optimization. I'm gonna call it geometry torus. Here we're gonna be the mesh scene. We don't need that. I don't know why it was duplicated. I'm gonna collect this torus mesh, that way I can use it everywhere. Okay. And okay, so this is just giant. Is it reflecting being reflected? I think yes. It's just like we have an optical illusion, but this is actually being reflected. And we can just make it smaller because it's just way too. So here maybe 0.2. Okay, and we're gonna probably change the position of it. So position y1 maybe. Okay, so as you can see, it's been reflected. Here maybe we can increase that value like that. Okay, cool. And we're gonna move it on the X and Z, like 3 Z, sorry, 3 as well, or -3. Okay, and we're gonna do the same. We're gonna make it move. Cool, but we're gonna change the time so it's gonna move faster, just to have a small delay, and maybe 2, something like that. Do what you want. And then we're gonna also apply a rotation. So to do a rotation, it's almost the same as position. It's just rotation. And here we're gonna increase by 1. It's going super fast, so we're gonna divide it by maybe 0, 1, 0, 0, 1. And we're gonna also apply that to the rotation X and Y. And Z, sorry. Okay, so we have something nice. And as you can see, it is being reflected in the mirror. And it's working pretty well. Okay, I'm just gonna. Okay. Okay, so now we have our mirror and it's working great. But I wouldn't do an exercise if it was just for that, right? That's too easy. So let's add some custom shader in it. So it's looking great, but we kind of want to have like this water reflection effect, right? Like it's kind of a distortion. So if you did that, maybe if you've seen that, sorry, maybe in the first episode, we used the displacement map. We're gonna do something similar and we're gonna apply it into our mirror to have this water effect. So first of all, let's see the reflector that Three.js is using. Okay, so we were in this mirror thing, then we access to the code by clicking here. And here we can see that it's using an add-on, an object called reflector. So here we are already in the Three.js GitHub, so we can go to examples, go to GSM, sorry, objects, and easy. Here you go, we have our reflector. So now let's have a look of what's going on. Okay, so first of all, it's taking a geometry. So that's the circle that we made. And then it has options. In the options, you have a lot of stuff happening. But you have a color, a texture width, a texture height, a clip bias, a shader. And by default, it's the reflector shader. Okay. And multi-sample. We are not going only to focus on these. So here it's doing a lot of things. And as you can see, it's using a render target. So the WebGL render target is something really important. It basically taking your current scene. So imagine you have these spheres and these torus, the whole scene, and from a camera point of view. And from this camera point of view, you are rendering the scene into a target. And then you can use this target, so this scene, you can use it as a texture, like as an image that is being updated 60 times per second. So that's basically doing is basically, okay, you have a scene, I'll take your scene, I create an image of it. Then you can use this image everywhere you want in your scene again. So you can kind of like render the scene into a sphere, for example, in your scene. It's kind of like Inception stuff, but here this is what we are doing actually. Because we are rendering our current scene, but we are taking it from opposite, right? It's kind of like the invert of it. And then we apply the texture of the scene into our circle. So that's basically what they are doing here. So I'm not gonna go into detail, but here, the T-diffuse is the texture of the scene. And then you can apply this texture into any object you want. And here we're applying the texture on the circle. So here you can see it's doing a lot of like complex, not really complex stuff, but basically using matrix, it's like inverting the scene and inverting the normals and stuff. It's doing it for us, so that's perfect. We don't have to do that. And that's it. See? So it looks pretty complex, but basically it's just reverting the scene and use it as a render target. Okay, and then if you go below, you can see that there is the shader. Okay, cool. So if we have access to the shader, that means we can create our own shader. So perfect. So that's what we're gonna do. We're gonna reuse the initial shader and we're gonna tweak it to do what we want. So for that, we're gonna use the reflector shader. So as we've seen here, as an option, you can put any shader that you want here. And here by default, it's using this shader. So we're gonna add our own shader. So for that, it's gonna be simple. We're gonna do shader. And we're gonna create a custom shader. This custom shader is going to be the reflector shader that is already working. But we are going to change the fragment here. So we're gonna keep the uniforms, but we're gonna change the vertex shader and the fragment shader. So first of all, let's use what we have in the GLSR. We have like a classic vertex shader and a fragment shader, but don't worry about that. And now we're gonna just replace them by this. So we are just basically replacing the code by our own code. Okay. So that's the vertex shader. And that's the fragment shader. We'll see what's happening later. Just clean it, making cleaner a bit. So now we're gonna import these files. Import vertex shader from GLSL slash that it was main. Yeah, main. And same for the fragment shader. So in case you don't know, a vertex shader is the program that is used for each vertices of your object. So for example, if you have a square, it's gonna be like the 4 points or the 6 points if it's two triangles. And the fragment shader is gonna be called for every pixel, and it's for the color. So vertex is a skeleton and a framework is the color. As you can guess here, we are only gonna use the colors, the flat part. We are not changing the position, we are not doing morphing, we are just touching what we see. And what we see is a flat mirror, so we're just gonna work on the flat part on the fragment shader. Okay, so now that we have importing that, we can add them. We can replace the reflector shader by our own shaders. And we're gonna do the same for vertex and the fragment. Actually, we could just keep the vertex shader as it is. But just in case we're gonna try stuff. Okay, and then we are saying, okay, let's apply this shader. Okay, yeah, sorry, it was reflector shader. Okay, and now it should work. Okay, it's working. So as you can see, nothing changed. But the cool part is that now we can custom the mirror effect because now the code is here. Okay, so let's give it a try. Let's, for example, change the color here into white. So this is a vector 4 of RGB and alpha. So if we want to add white, it's going to be 1, 1, 1. Because each value are between 0 and 1 in shaders. So here I'm using white. Hey, okay. Well, looks like it's working. We can now change the thing. And if we want to make it red, for example, 1, 0, 0. Yeah, okay. It's the classic red from RGB. Okay, so for now, let's go back to what we had. First of all, let's see what's going on here. So here in the vertex shader, basically, it's using a texture matrix and it's multiplying that by the position and adding that to the UV. So basically, this is like a way to invert the UVs of the scene. So to basically mirror the scene. And once you get the UVs of that, you are passing that to the fragment shader. And here in the fragment shader, it's using the T-diffuse. So remember, T-diffuse is the texture of the scene. And it's using the UVs, so the mirrored UVs. And then it's using what we call the blend overlay. We'll see that later. And basically, it's just saying, okay, take the texture of the scene, apply the UVs, the mirror UVs, and that's it. So basically, take the scene and make it mirror, changing the UVs. Here you can see we're on the blend overlay color. Well, that's because, yeah, I don't know why actually, but it's using color to blend and make the color different. So we don't really see it in the white, but we see it in the blue, right? It's not exactly the same blue. So if I remove this, okay, now you can see it's exactly the same color reflection. So we don't see any limit between the reflection and the actual scene. So we can try, for example, to add different colors, for example, full white. Okay, and it's super bright, right? It's like blending the color. And actually, I don't really like that. But I think it would be still cool to make the mirror not exactly at the same color of the scene, actually, because if you look at a mirror, if maybe the mirror is a little bit dark or something, it's not gonna be the exact color of it. Like here for the effect that we want water reflection. And so the color of what you see in the water is not exactly the same color as it is in the sky. So for that, we're gonna use something super useful. We're gonna use something that is already a function in GLSR. And this function is called mix. And mix is basically giving you a mix value between two colors. Super convenient. Like for example, I know you say white from black, and it's gonna do a perfect gray. If you put the last value is gonna be the threshold kind of. So if the last value is 0.5, it's gonna be gray. If the last value is 0, it's gonna be black, and if the last value is 1, sorry, it's gonna be white. So we're gonna just use that, and we're gonna remove all this stuff because we don't need that. And we're gonna say, okay, mix the color of the scene and mix the color that we are giving here, this color. And we're gonna say, okay, 0.5. So it's kind of gonna be the transmission. So here, as you can see, it's kind of working because it's adding a gray effect on it. Okay, so first of all, so now I want to make it darker a bit. I think that's what I was doing in the... So I'm gonna use a black color, and here you can see it's being reflected, but it's darker. So it's kind of like we want here, because here, as you can see, it's a bit darker on the reflection, and this value is the reflector transmission that I put. And here you can see I can make it even more dark, so it's like kind of more natural because maybe the water is darker, something like that. And if I put it to 0, it's gonna be just a mirror, perfect mirror. So it's gonna be how reflective your mirror will be, kind of. So okay, so we have done it already. It's working. But first, let's increase the circle because I think it's make more sense. Okay, so now we have like a reflection that is a little bit darker. So I think it's great. That's kind of what we wanted. And should change this stuff. We don't need the material here. Okay, and we can use... Okay, so now let's talk about the other option that we didn't mention. So we talked about the color. So now we are using this color here to make it brighter or darker or whatever. But now let's see the others. So the others are the clip bias. So the clip bias, I don't know how to pronounce that actually, is how close you want to be from the camera, how close you want to remove the effect if you're close to the camera. So for example, if you put the clip bias to 1 or to 10, if your mirror is close to 1 or to 10 from the camera, it's gonna just cut the effect and you won't have the mirror effect. So that's basically improving performance. Like if you're really close to the camera, you don't need to render the scene totally. You just want to render while it's pretty far from your eye. So that's basically it. Here, texture width and texture height is, remember that we are rendering our scene as a texture, and that's I would say the quality. So like retina or like multiplied by 2 or not. So here, this is multiplied by 2. But the thing is, when you're using a render to target, it can be pretty heavy to compute and to do calculations. And we are already using here a DPR, so a device pixel ratio of 2 if you have a retina device. So that means we're gonna do almost like 4 times the calculation. So here, since we are gonna add a water effect, I think it's better to only use, to not multiply the texture by 2. I think just a classic texture is enough because it's gonna be watery anyway, so you won't see like really the difference between a time 2 quality versus a 1 quality. So I think for performance reason here, it's better to keep it not multiplied by 2. Okay, so now let's see how to make this water effect and apply it into our mirror. So again, let's check of the Three.js example. And we have something called refraction. And refraction is actually what we want. See here how the sphere is like being like distorted, right? Displaced, right? By the texture. So we're gonna reuse this shader and we're gonna apply it to our mirror. So for that, we're gonna have a look at the code. And here you can see it's using a water reflection shader. And that's actually what we're going to use. You can also see that it's loading DUDV map, and that's the map that is being used to make this water effect. So you have a texture and you have a shader. And the shader is using the texture to add the displacement to the final render. So, okay, let's see. In that case, we can just get inspired by the water reflection shader and see how it looks. So we're gonna do the same thing. We're gonna go to object in the library, but this time it's not object, sorry, it's gonna be in shaders. So example JSM shaders, and okay, it's the last one, water reflection shader, and we're gonna have a look. So here it's using uniforms, it's using a vertex shader and a fragment shader, of course. And you can see here in the vertex shader, it's using a VUV reflection. But if you look closely at it, it's already what we have in the vertex shader that we're using. Because here in the vertex shader, we're using the texture matrix of Three.js, and we are using multiply it by the position. So that's the same thing as the VUV. So we can basically guess that this VUV reflection is gonna be our VUV. So we can just use VUV instead of VUV reflection. And here, let's see. It's curious, it has exactly the same, it's really similar, right? It has the same blend overlay, the same texture 2D approach. But here we're gonna use this. And this is what creates the displacements. So just copy and paste. As you can see, it's being used just before the base. Okay. Okay. So now let's have a look. So we have a wave strength, a wave speed, and here we have a distort UV. So remember that we were flipping the UVs before to add this effect, but now we're gonna distort the UVs. Here, as you can see, it's using a TDUDV. That's basically the map that we don't have yet, but the one that is used here. So this thing. So we're gonna grab this thing later and we're gonna just use it. But for now, let's have a look. So it's using the texture and it's taking the VUV. So remember these UVs. And it's applying an effect, right? It's changing the x-axis of the UV, so horizontally, by the time. We don't have the time yet, but I guess it's something that is increasing, that we have seen with the sphere moving, with the wave speed. So we can say that it is being displaced on the horizontal part of it from the texture, but only for R and G. And then it's multiplied by a wave strength. So it's basically how strong the displacement will be. So once this is done, this is getting other effects on top of that. It is getting the basic UVs, so the first UVs, and it's using again other displacements and distortion, but this time this distortion is in the y-axis. Okay. Finally, we have a vec2 distortion. It's using again, it's getting destroying this form. That's basically what it's making looking great here. It's why it's looking really distorted. That's because of these changes here in the code. And then we get our new UV coordinates using the VUV reflection. And we are applying the distortion on this UV. Okay, let's first load the texture. So it's gonna be maybe easier to have the result directly. Okay. So here what we can do is we can use networks and we see that that's the texture that we want, right? So we can open it and so we can finally see the water texture. So it's looking like this. As you can see, there is a green and a red. These values are being used to displace anything you want from that. So it's kind of like similar to the first episode. I invite you to watch it. Okay, I'm just pausing the video now because I forgot to explain, but this kind of technique was used in all video games to recreate water because it was super cheap. As you can see, we are just using one texture and we are just using the green and the red channel of the texture. And with that, you can apply some movements on your shaders. And usually what they were doing was you can move your water in one direction and then reuse the same shader and move it in the opposite direction. That way it's kind of like recreate how water moves in lakes or something like that. I just wanted to mention that. Okay, so we have our texture. We just have to download it. So we're gonna add that to our src public file image file, and we're gonna call it water. Okay. Cool. So now that we have it, let's do the same thing here. We're gonna load it, but like for the other exercise, we are using a loader manager. So here we were already using the matcap. We don't need it anymore. So now we can load this image. So we're gonna call it water du dv. And it's a JPEG. Okay, so with this loader manager, everything that is below this code is being called after everything is being loaded. So we are sure that the image is loading before we initiate anything. So now here, let's see in the refraction code. They are using here the texture logger, and they are making it repeat wrapping on the SNT. That basically it means, make it repeat infinitely. So our water will be infinite. So here in the reflector, let's do the same. So here we don't need the texture loader. We can just call the loader manager .assets, call the name of our image, water dudv, and texture, and is already there. That's why I made this loader, because it's super helpful to load anything you want. So we have our dudv map. Then we have to call Three.js here for repeat wrapping. So let's just import it like that. And here we have to add this to our custom shader uniform. So to do that, we're gonna do custom shader uniforms, and we're gonna add duv right uniform because we don't have it yet. I'm gonna put the value, and the value is going to be the map. Okay, so now that we have that, that means we are adding a uniform with our duv, and here in the fragment shader, we are using that, right? So we can just use it as well and add it here. Okay, what are we missing here? We are also missing the time. So let's add time value. It's gonna be 0 for now. We don't really need it. Don't forget to import it here in the uniform. So it's a float. It's gonna be a float number, time. And I think that's all we need. Then remember, we are not using the VUV reflection, and we already have this value. This value is VUV. So we're gonna just use VUV and put it here. Then here we want the final visual to be the distorted UV. These are just the normal UVs from the beginning. First of all, let's see if we have something. Okay, I think it's working. Right. But now we want to use, so here we're using the normal UVs, but we want to, I mean, it's not normal, it's the mirror UVs, but we want to use the mirror UVs displaced. So the displaced UVs are here. Just need to replace. And, oh, look like it's working, right? It's already working, amazing. So as you can see, we have like kind of water. But since the water is not moving, it's more looking like an ice, right? Maybe that's a good idea to be creative, and in your exercise, maybe you can, I don't know, do a mountain with some ice, iced lake, for example, and you can just use that. And it should look pretty cool, I think. Cool. So now that we have that, we want to make the water move. So for that, we need the time. And remember, we are not changing the time. So let's do that. So remember, we have a uniform here for the time, but we need to change it. So we're gonna do here when we are drawing stuff. And we need also to color ground mirror. To get access to that, we're gonna use ground mirror, material, uniforms, and time, and value. And we're gonna increase it by 1. Okay. So it's working, but it's going super fast. So let's add maybe 0. No, 0.1 or even that. Okay, I think it's working great. But now let's see how we can tweak the values to make it more like it's water. So the good thing for us is that we already have a value just for that. It's called wave strength. And we can just easily change it. As you can see here, it's now applying less distortion to it. So I think it's looking great. If you want, you can always add it as a GUI like that, and so that way you can modify the values. So that's what I did here. This is the wave trends. So here you can see how it's working. And I think 0, 0, 1, it's looking great for water. But you can always change if you want. And we also have the wave speed. So again, that's working with the time actually. So if you change the value of the time or the value of wave speed, it's gonna do the same. Okay, so I think it's looking great. Yeah, I think that's pretty much it. Now, let's make it a little bit more beautiful by first of all removing this three color stuff, whatever, and add a sky. Okay, so first of all, let's remove this axe. Here is the axis helper. Axis helper. Okay, cool. Looks better already. Now, kind of feel it's kind of too dark. Oh, I don't know. No, I think that's great. It's really Dark Knight stuff. So we're gonna add stars. So for that, simple, we're gonna use particles. And actually we're gonna do almost the same thing as we did in the episode 4. So feel free to have a look because we're gonna do the same thing already, almost. Remember, we're gonna use buffer geometry. And we're gonna use points and points material to create basically stars in the sky. Okay, so buffer geometry. Yeah, okay. I think Threejs changed since the last time because now it's everything is commented. Weird. I will call Mr. Do about that. Maybe send him a message on Twitter. Yeah, because this should not be commented, right? Yeah. Okay. Yeah. So basically, I'm gonna use a buffer geometry, and we're gonna import it from Three.js. And in this geometry, we're gonna put the attributes, materials, and the mesh. That small bug on the dock. And we're gonna add the mesh to our scene. It should be. Okay, so it should be a red square or something like that, yeah. It's a red square, but it's in the water, and that's cool. But that's not what we want. So here we're gonna use point materials. So that's how you make particles in Three.js and points. So now we have 2 points, actually 4 points. And now we're gonna play with point materials and the number of particles to improve that. So we're just gonna do a loop actually, and we're gonna do it's really like it's the same thing as the episode 4 actually for that part. So we are making an array of vertices, then we are making points. Points are going to be a new vector 3 from Three.js, and it's gonna be, but this time we're gonna use random values. So we're gonna use random float, and we're gonna dispatch the particles everywhere in the scene. Now I have to remember the good values to make it great. I think I was using like a range, and the range is going to be like how big our square will be. So maybe 200. So from minus range to range. So it's gonna be from minus 200 to 200 on the x-axis. Then up, it's gonna be pretty high because we want it to be in the sky, but also not too high, otherwise we won't gonna see it on the horizon. I just need to remember the numbers that I found because it was working well. It was 20, 200, and then the z will be the same. Okay. Then we are going to do we're gonna push this with the spread operator, remember, so that way we can register this array with all the coordinates following each other and not array of arrays. And that way we can just say plot array 32 of vertices. This guy. You can remove that. Here, how many particles do we want? Probably 1000. Wow, okay, it's already working. Yeah, I think it's looking great like that. And maybe we want, of course, the particles to be white. maybe 10 here. Yeah, what do you think? Looking better, right? If you want the particles to be round, you can always use map, actually. I think it's in point materials. But yeah, basically you can check the code here and see how they did. But basically, yeah, here you can use a point texture or just a map, I think, and load a PNG, like a sprite PNG of a circle. That's what I did in the demo. And so that way the particles will look like more stars. Okay, I think that's it for this episode. I hope you guys learned something. Please send me your work, like if you manage to go here, send me your work, and maybe if you make, I don't know, something different with the reflection, like I said, like a iced lake or something, I'd be super curious to see your works. And yeah, as you can see here in the demo, I added a moon, I did more shapes, I added some GUI to change the waters and stuff like that. So yeah, be creative again, and I'll see you in the next episode. Bye.